Let's solve this question. Consider a large disk of radius r and two smaller disks, each of radius r is equals to r upon 50. So smaller one thing is given is small r is equals to capital R upon 50. Okay. Lying on its circumference as shown in the figure. Okay. The smaller disks are initially in contact with each other with an angular separation delta theta between their centers. They are made to roll without slipping in opposite direction with constant angular velocities omega and 2 omega, while the large disk is held stationary. The time tau at which the smaller disks are again in contact is. So what is the question is asking basically कि ये दोनों डिस्क रोल करेंगी विदाउट स्लीपिंग and after some time they will meet somewhere. So suppose they will meet somewhere like this position, because like this one is moving with omega and this one is moving with 2 omega, so it will cover more distance and it will cover less distance in some time, and after some time they will meet, and the question is basically asking that time. Okay, so let's first find out the distance they will travel during their whole journey. Okay, so let's draw this diagram. This radius is r and the smaller radiuses are small r. This is also small r, and from here also we can see, if we join this, the total distance covered by them will be this, the bigger circle. Okay, and the radius of this bigger circle will be r plus small r, because this is smaller. तो circumference क्या हो जाएगा इसका, is equals to 2 pi capital R plus R. Okay, now initially they are separated by this distance, so this distance will be subtracted from here, 2r. Okay, similarly when they will meet, that separation will also be 2r, so that will also be subtracted, minus 2r, and we are taking this as similar to the sum of these two radiuses, because delta theta is very small, okay, comparatively, and these radiuses are also very small, so that's why we are taking this as this distance as 2r. Okay, so the distance traveled will be is equals to, circumference is this and this is the basically distance travel, so 2 pi r plus r minus 4r. Okay, now from here we can take two paths. Okay, one is, suppose we take this distance x, this distance will be the whole distance minus of x, we find the time for this and use that equation in this one, and then solve for time and find the time period. Another way is we find the relative velocity of these two velocities as they are approaching each other, so their combined velocity will be, they will add up. Okay, so suppose one object is moving in this direction and other is moving in this direction with some velocity va, and this is vb, so their combined velocity is va plus vb. Similarly we can do something like this here, but for that first we need to find out the center of mass velocities. We know that center of mass velocity formula is r into omega, but in this case we have r is small r, so small r times omega. For disk 1, v center of mass is equals to r omega. Disk 2, v center of mass is equals to 2r omega, because it is 2 omega, it is moving with 2 omega. Okay, so combined velocity will be r omega plus 2r omega is equals to 3r omega. Okay, we know the distance, we know the velocity, we can find out the time period. Tau is equals to, distance is 2 pi capital R plus small r minus 4 times small r divided by 3r omega. We know that r is equals to capital R upon 50. Put this here. What we will find that tau is equals to 2 pi r plus r upon 50 minus 4 into r upon 50 divided by 3 times r upon 50 into omega. Okay, so here what we can do is tau is equals to, this will become 51 r upon 50, this is r upon 50, this is r upon 50. What we left is 2 pi 51 minus 4 upon 3 omega. Okay, so now we can see in what form our answers are. So they have taken 51 common. Okay, so we can take 51 common from this, and we get 51 upon 3 omega multiply by 2 pi minus 4 upon 51. So this will be our time period. Do we have this option? I guess this is the option. 51 2 pi minus 4 upon 51 upon 3 omega. So option 3 is our right answer.